All right, today let's talk about the elimination method as a way of solving linear systems. So if you're following along with notes, you may want to copy things down. Here's your topic and essential question for today. Feel free to pause at any time during the video if you need additional time to write things down. All right, so I want you to first just think about what does it mean to eliminate something. Well, hopefully you decide that eliminate means to get rid of something or to cancel out. That's really what we're going to try to do today when we're solving linear systems, is we are going to combine two equations together by adding the like terms in a way of eliminating one of the variables. Now, this can get a little bit more complicated, but today all the systems that we're going to solve will be set up quite nicely for us to use elimination, where when we add the equations, terms will eliminate right away, even though that doesn't always happen on its own. So here's our system of equations, and we want to think of this as just like we do single equations. Equations are like balances. The left side has to balance out with the right side. It has to have equal amounts. That's why it has an equal sign in the middle. So when we have a system of equations, we actually have two equations that have a left side and two equations that have a right side. And because it's all part of the same system, we can actually take each one of these parts on the left-hand side of both equations and move them to the left side of the balance. And then we can move the other parts to the right-hand side of the balance. So see, left side of the system has to balance out with the right side of the system. Well, if that's true, we should be able to combine these like terms and see what we have in total on both sides of the balances. Now, when we do that, keep in mind, anytime you have a variable, there is a 1 in front of that variable as a coefficient. So when I combine my like terms of x and 5x, I add together as 1 plus 5. Well, 1 plus 5 is 6. So that would give me 6x. And then when I combine my y's, so here, -2 plus 2 is 0. Because remember, anytime you add opposite values, like -2 and +2, it's always going to add up to 0. So we have 0y. And then our equals is like our middle of the balance. And on the other side, we just add together the constant terms, 20 and 16, to get 36. Now, when we did this, we actually eliminated one of the variables, the one who had a coefficient of 0. So we don't really even need 0y there. So when we combined our like terms, we get this equation now that only has one variable in it. We just have an x. And if we only have one variable, we can solve for that variable. And we get x equals 6. Now, we would then have to take this value of x equals 6 and substitute it back into either one of these equations and use that to solve for y. So let's say I wanted to take the first equation just because I like how the numbers are smaller and there's fewer coefficients. And I'm going to do a substitution. So since we know x equals 6, I can replace x with the number 6 and solve this equation instead. To undo this +6, I want to subtract it to the other side. 6 minus 6 is 0. 20 minus 6 is 14. And I can either use mental math here or I can divide by -2 on both sides. And I see that y has to equal -7. So remember, the solution to a system is an ordered pair, so a value for x and a value for y that makes both equations true. So in this particular system, that solution is 6, -7. Let's look at another. So here we have x plus y equals 10 and x minus y equals 2. If we use that same concept of balancing the system, let's take a look at what do we have on both sides. Well, on the left-hand side, I have an x and another x. Remember, all of these have a coefficient of 1. So 1x plus 1x is 2x. 1y minus 1y is 0y. So that's basically like not having that. That's the one that eliminates from this problem. On the other side, I had 10 and 2, which equals 12. So I get this equation that 2x equals 12, which I can then use mental math to solve, or I can divide by 2 on each side. And I get an x value of 6. Now, it's not your final answer, because remember, a system has a solution that contains two values, the x value and the y value. So now we have to plug it back in and figure out what the y value is. So I can choose either equation here. Do I want to work with x plus y equals 10 or x minus y equals 2? I'd rather work with the addition, just because I think it's easier to work with addition than subtraction, even though it would work out the same in either case. So if I use x plus y equals 10, and now I know that x is 6, because my first step solved for x, I'm going to go ahead and replace, change the x to 6, and then I see that 6 plus y equals 10. I can use mental math there. It's 6 plus 4 equals 10. Okay, or I can show by solving 10 minus 6 equals 4. So my solution is 6, 4. And you might be wondering, Mr. Brown, what if I would have picked the other equation? Would I have gotten a different answer? Well, let's check. If we use that second equation, that x minus y equals 2, we're still going to substitute. So the only thing we knew up to this point was that x had a value of 6. So let's put a 6 there instead. And we would, let's see, get rid of that 6 by subtracting 6 on both sides. Or maybe even, you know what, it might even been easier to use mental math in this case, because otherwise it turns out to be 2 steps. So if you think about what does y have to be? 6 minus how much equals 2? Well, I know that 6 minus 4 is 2. So y has to be 4. Might be the easier way to do that. Okay, and we just have to remember to put our x and y together as an ordered pair in our final answer. So it doesn't matter which of these two equations you use when you're trying to figure out the second variable. They'll both give you the same result. Let's look at another one. So we have x minus 3y equals negative 13, and negative x plus 4y equals positive 15. All right, so think of this as a balance. I'm going to go ahead and actually move this out of the way. This is how I do this without the balance. Okay, I draw a line underneath it to show I'm combining my two equations. And they weren't really lined up. And I'm going to draw my line on the equal sign, or even train tracks, to separate left side from right side, just like we have on that balance. So I want to combine all the like terms on the left. And I see that I have 1x minus 1x. Well, 1 minus 1 is 0. So that essentially is going to cancel out. That's the one that eliminates. Now, when we add the y terms, we have to remember that this isn't just 3 plus 4. It's a negative 3 plus 4. You can always double check. So negative 3 plus 4 is positive 1. So we get 1y equals, and now we have to add here, negative 13 plus 15 should be positive 2. Yep, positive 2. So 1y equals 2, and we know that 1y, 1 times y, is just y. So really, the y value is 2. We know half of our answer. But we still have to figure out what x equals. So this is where we have to go back to the original problem, pick one of these two equations, and decide which one you want to use to solve for x. Doesn't really matter. I see that, you know, in my first equation, if I'm trying to solve for x, I already kind of have x by itself because there's not a number in front of it. Like down here, there's a negative 1 in front of the x, so it's going to produce an extra step. So you know what? I'm going to use the first equation. X minus 3 times y equals negative 13. You might be wondering, well, why did you do parentheses around the y? Well, I did that because that's what I know I can substitute for. I know that since y equals 2, I can replace y with a value of 2 now, and I can use that to solve this equation. So I multiply first. 3 times 2 is 6, so it's x minus 6 equals negative 13. I'm going to undo the subtraction by adding on both sides. And I get that x has to equal, well, let's see, it's negatives. I might want to double check this. Negative 13 plus 6, enter, negative 7. There we go. Again, if we would have used the second equation instead in this step, we would have gotten the same results. It just might have been a little bit more work because of this negative in front of the x. Don't forget, you can always double check your answers by entering these into a Desmos graphing calculator, and you want to look for where these two lines intersect, and they will intersect at the point negative 7, 2. All right, one last problem, but what I'd like you to do is pause the video, try this on your own, and when you're ready, hit resume to see how you did. All right, so here we're going to combine our like terms. We've got our left side separated from our right side. And on the left-hand side, we're combining the x's first. So 2 plus negative 4 is negative 2. So we're going to have negative 2x. Then when we combine 1y plus negative 1y, that's actually going to add up to 0. Okay, that's the part that's going to eliminate. Now on the other side, we should have gotten positive 4 when you add negative 9 and 13 together. So it looks like we can just use division to solve for x here. We divide it out, we get x equals negative 2. Remember, that's not your final answer, that's just the first half. We still need to solve for y. So we pick one of these two equations. Let me see which one might look better here. Let's see, we know what x is, we're trying to figure out what y is. So again, I'm looking at, well, because y here is already just plus positive y and not minus a y, I think I'm going to want to use the first equation again. It just kind of worked out where I think the first equation looks a little bit easier each time. So 2x plus y equals negative 9. Let's see, what do we know? We know that x is negative 2, so I'm going to replace that with negative 2. And then we need to solve. So 2 times negative 2 is negative 4. And it looks like to get y by itself, I would have to add 4 on each side to get rid of that negative 4. Let's see, negative 4 plus 4 is 0. That eliminates. And on the other side, negative 9 plus 4, better double check. I believe it's negative 5. Whoops, I hit the wrong button. Negative 9 plus 4. All right, your calculator is only going to do what you tell it to. Yes, it is negative 5. So we substitute that back into our answer, and we get negative 2 comma negative 5. You can always double check by putting these equations into Desmos and looking for where do the two lines meet. And the two lines should meet at the ordered pair, negative 2, negative 5. So that's the elimination method, where you're really just adding the like terms together in the two equations. And when you do that, you should get a pair of variables that eliminate because they add up to 0. And then you can use that to solve for the remaining system.